Okay, before we actually get started on this problem, I'm going to draw a velocity versus time graph because it's probably a little different than what most of you are used to. Most velocity versus time graphs still have the v, so the y-axis isn't crazy, but the x-axis actually comes at a different point than you are probably used to. It doesn't come down here at the bottom. They usually kind of throw it in the middle because a lot of the time we also have to worry about the negative regions, right? So down here we have -1, while up here we have +1 and +2 and +3 and so on and so forth, and -2 down here. This line for the x-axis is 0 velocity, okay? Now we want to calculate the slopes of each of these sections. So simple enough, we go 3 seconds is our run, 6 meters is our rise. So 6 divided by 3 is simply 2 meters per second. For now, that's all we have to do for this part, right? So 1, 2, 3. So for 3 seconds, our velocity is 2 meters per second. It's just a flat line. The reason we know it's a flat line is velocity is constant, so it's not changing or anything. So we don't really have to worry about any changes. It's just a flat number. Now we come over to here for the next 2 seconds. From 3 to 5, we do 0 rise divided by 5 minus 3, which is equal to 0 over 2. So for this region, we have 0 meters per second. One of the most common errors in this class that happen is people are trying to calculate the average velocity of the total time, but all we're worried about is the average velocity of this region of time. If they were to ask you the average velocity from 0 to 5 seconds, then this wouldn't be the right answer. You would want to calculate from this point to here, but we really don't do that too often, okay? So don't stress about that. When we're asking for average velocities, we tend to look at each region in little chunks. Now, if we were to come over here and graph it for the next 2 seconds, all of a sudden our velocity changes, and we've got 0 meters per second, and you connect the dots to here because there's a significant slope change. If what I said earlier about the whole average, whatever, blah, 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 doesn't make sense to you, don't worry about it. You're fine. If you get this, you're good to go. Now over here, we're actually walking back towards our origin point. So we walk for 5 seconds to 8 seconds. The difference between that is 3. And we only travel a -3 meters. We know that because 6 is our starting point, 3 is our ending point. So we go backwards 3 meters. If we plug this in, we do our rise, which is -3, over our run, which is -1 meter per second. For 3 seconds, 1, 2, 3. All of a sudden we come down here. It goes down, and we are at -1 for 1, 2, 3 seconds. And if we even want to double check, right now that should be 8, and there should be 1, 2, 3, 4, 5, 6, 7, 8. Oh my God, you compare the two, and you're good to go. Then all of a sudden, we're back at 0 for the remaining amount of time. And our graph will look like this for our VT graph, right? Oh, I didn't mean to put an arrow there. But this is all you really have to do. It's pretty straightforward. Just make sure that when a slope change happens, you're only calculating the slope for those regions of time. You're not trying to do the overall time. Cool. Just in time.